Hi everyone. Today we are going to talk about square roots, cube roots, and higher orders. So we're going to review square roots. You probably remember square roots look like this. They use the radical sign. And we have the square root of 169. We're looking for a number that when multiplied by itself, it gives you 169. You may think, oh, that's 13 squared. 13 times 13. Absolutely. So the square root of 169 is 13. If you'd like to think about this differently, you could think, okay, if my area is 169, what number can I put to multiply the length times the width to get 169? That's 13 times 13, right? So the square root is like that side length there. There are a few other things that might be helpful as you're thinking through sort of tricks of the trade. So the square root of a fraction is the same as the square root of the top over the square root of the bottom, like that. So square root of 4 would be positive 2. Square root of 9 would be positive 3. There is a plus or minus version. We're not going to talk about that in the scope of this video, but you do have plus and minus with your answer there. So 2/3. Trying to take the square root of a negative number. If you try to think of those two numbers again, you might say, oh, 36, that must be 6 and 6. It is, but you would need to have either positive 6 and positive 6 makes positive 6, or negative and negative still makes positive 36. So no two real numbers are going to give you negative 36. And so your answer here is no real solution. It does have an imaginary solution, but no real solutions is the answer for number 3. And then number 4, this is just the idea that if you have a number that's being squared and you're taking the square root of that, the square root and the square will cancel and leave you with just the number that you started with. So in this case, x. If you think about this a different way, you might think like, okay, what's the square root of 3 squared? You could say, okay, the square root 3 squared is 9. And what's the square root of 9? Oh, it is 3, right? So what we've just been doing here is called evaluating, right? Evaluating. We're finding a singular number as our answer, right? So we found 13, 2/3, no real solution, and then x here. What we're going to try next is called simplifying. And you probably remember this from your past math classes. But when we simplify, we try to take out anything that is a perfect square. So what I'm going to do is I'm going to use a factor tree. I'm going to go ahead and say like, oh, what goes into 124? I'm not sure off the top of my head. You might be, but I'm definitely not. So I'm going to use a calculator. And I know it's an even number, so I will try like 124 divided by 2. And I see 2 and 62. It's a whole number, so I'm going to use it. So 2 times 62. Might say, okay, well, 62 is still an even number. 62 divided by 2, it's 31. So I have 2 and 31. I'm going to go ahead and cross out 62 because I used it up when I split it into 2 and 31. Right, 31 is not an even number, so I'll try 31 divided by 3. And that's a decimal, not going to work for me. Divided by 5, nah. 7, no. 8, no. 9, no. I'm saying no because they're decimals. 11, I'm pretty sure that this is a prime number because there are no numbers that are going into it. I might try all the way up to 15. Yeah, definitely not working for me. So I know 31 is a prime number. 2 is also a prime number. Right, so 24 is 2 times 2 times 31. If you get to this step and you want to check your work, you can always go over here and type 2 times 31. And you can see, oh yeah, it's 124. So I know I did it correctly. What I need to do now that I've found my factor tree is I need to find my groups, right? So I have a group of two 2's. So that 2 can come to the outside of my square root. I'm going to go ahead and write it here. 31 does not have any pairs. So it's going to stay on the inside like this. It has to have a pair in order to come to the outside. So this is the simplified version of this here. I can double check my work by saying, okay, square root of 124 and square root of, or 2 square root of 31. I see that they are the same number, so I know that they are equivalent. So this is my answer for this problem. Okay. I can do the exact same thing if I have variables in here. So I'm going to make groups. So 24, break down 2 and 12, break down this into 2 and 6, break down 6 into 2 and 3. I know that I have one group of 2s, and then 2 doesn't have any more friends, 3 doesn't have any more friends. The 6 was used up. So this group of 2s is going to the outside. The 2 and the 3 have to stay inside. So 2 times 3 will stay in together. Inside will be 6. Like so. So 2 root 6. Now I'm going to deal with my variables here. So I have 3 x's. I have a group of 2. So that's an x on the outside. And this one's left over. That's an x on the inside. So the group makes 1 on the outside. This one makes another 1 on the inside. For my y's, I have 5 y's. So I have 1, 2, 3, 4, 5. I'm looking for groups of 2. So I have 1, 2 full groups, right? So that is y squared. Yeah. And then that y is left over. It doesn't have a pair, so it's going to stay inside. Basically, these are the groups and these are the leftovers. So I'm going to go ahead and make this. I'll move it over a little so I have more room because I still have my 9 z's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So I have 1 group, 2 groups, 3 groups, 4 groups. So I have z to the 4th on the outside. And then I have 1 left over. So it's going to be a z on the inside here. This whole thing, all the way with all of these colors on it, this entire thing is my answer for this type of problem. Right, so I took my numbers, broke it down, found the groups, put the groups on the outside, leftovers on the inside. Same thing with my letters. Wrote them all out, made groups, groups on the outside, leftovers on the inside. Okay. So this is how I work with square roots, right? I'm finding those pairs to move to the outside. I do want to talk just quickly about some vocabulary. This little number, so we're going to move from square roots to cube roots and fourth roots. Square root looks like this. A cube root has the little baby number right there. And that little baby number is called the index. The square root doesn't have one. If there's no index, it's assumed that it is 2, right? It's assumed that's 2. So this is 2 right here, square root. Right? But if there is a number there, like 3, cube root, 4, fourth root, that is our index. This radical sign right here, this little like check mark looking thing, that's called a radical. And the number inside, or the letters inside, is called our radicand. Radicand. Learning some cool new vocab. Cool. So we have our little baby number, it's called our index. It's not an exponent. It's kind of like that size though. And then we have our radical sign and our radicand. So the big difference here when we have larger roots or higher order roots, if we have square roots, we're looking for groups of 2, as we saw in the last 2 examples. If we have cube roots, we're looking for groups of 3. And if we have fourth roots, we're looking for groups of 4. I'll show you what I mean here. So let's say we have this problem here, 2 times the cube root of 243. So I'm thinking, okay, 243, it's not even, so it's probably divisible by 3. I'm going to click here. 243 divided by 3 is 81. So 3 and 81. I know 81 is 9 times 9. I know 9 is 3 and 3. I know this 9 is 3 and 3. Right? There's nothing that can go more into 3, so I am done. This time, since my radical is a 3, right, a cube root has an index of 3, I'm looking for groups of 3 of a kind. So I have 1, 2, 3 threes. That is my group. So I can't just do 2. I now need to do 3 of them. So that 3 is going to come out to the outside. And this 3 and that 3 are going to stay inside because they don't have a group of 3. So I have the original 2. I have the group of 3. And then I still have my cube root. And then I have 3 times 3, or 9 on the inside. 3 times 3 here. I'm going to go ahead and simplify this by saying, okay, 2 times 3 is 6. And I have cube root of 3 times 3, which is 9. So this is the simplified version of this here. All right. Let's look at a fourth root then. Right, a fourth root here. I'm going to be looking for groups of 4. My index is 4, so I'm looking for groups of 4 of a kind. 4 of a kind, not like the number 4, but 4 of a kind. So 160, I know, is 10 and 16. 10 is 5 and 2. 16 is 4 and 4. 4 is 2 and 2. 4 is 2 and 2. Right, so I have all prime numbers here. I'm looking for a group of 4 of a kind. I see that there are 4 2s. So I have all of these 2s together. And then I know I have a 5 left over and a 2 left over. So I am going to take that 2 to the outside. And then I have the fourth root this time. And I have 5 times 2 left on the inside. I have a 5 here and a 2 left over. They're left inside. So I have 2. Fourth root of 5 times 2 is 10 left over like that. And I have my final answer there. Okay. If you are in regular algebra 2, you're done for today. If you're in accelerated, let's do just a couple more here so we can make sure that these make some sense. So take a moment to write this one down. We have the cube root of negative 64, x to the 10, y 21. So the negative I want to deal with, I know 3 negatives would make them positive. So negative times negative times negative. That means that this negative can escape out to the outside. And so we have negative, negative, negative. That makes a negative outside. And then 64 is 8 and 8. This is 2 and 4, 2 and 4. This makes 2 and 2, and 2 and 2. So I'm looking for groups of 3, like groups of 3. So I have 3 2s and another 3 2s. So the negative is coming here. I have this group of 2s coming here. This group of 2s is coming to the outside there. I don't have anything left over, so there's not going to be any numbers left on the inside of my radical here. So I have x to the 10th. I could write them all out, right? I could write them all out, and then I could say, okay, there's 1 group, 2 groups, 3 groups, or as you would imagine, I could also divide, right? How many groups of 3 go into 10? 3 of them, so I'm going to write x to the 3rd. And how many are left over? There's 1 left over. I'm going to put that x on the inside here. And then y to the 21, I don't want to write 21 y's. That's a lot of y's. So how many groups of 3 would that make? It would make 7 groups. So I have y to the 7th. Are there any left over? No, there's not. So my final answer, I'm going to multiply these 2's together. I get negative 4 x to the third, y to the 7th, cube root of x. Be careful here. You have some exponents and you're going to have this index here. The index should go inside the little crook, like the little arm of the radical sign. So do make sure that it goes in there. We don't want it to look like this because that would mean that there's an exponent here on whatever this is. We actually want our little number, our index, to go the inside of that radical sign. Let's try one more here. We are going to use that same trick that we learned. So how many groups of 4 go in here? Well, that's going to make one group of W's on the outside. There's none left over. And then how many groups of 4 V's could we make? We could make 4 of them. And we would have one left over. Let me put that V in here like this. This is my correct answer for this one here. All right, thanks, y'all. Ask as many questions as you have.